Iniziamo, no? Tutto a posto? Okay. So, can you hear me here? Yes, I guess you do. Can people hear me online? Do they say yes? Okay, that's good. So good afternoon, everyone. So I'm getting the industrial panel started, and I'd like to do so by inviting to the stage the speakers who will be afterwards the panelists. So we got the honor to host representatives of 5 big companies that represents application of AI in 5 different realms. And so we will have ST Microelectronics, KPMG, Leonardo, Image S, and NVIDIA. So what we'll do is I will invite the speakers to come on stage. The presentation is already here. They have got, we will proceed in the following way. We will be having 10 minutes for each of the speakers. They will introduce themselves, and they will tell us about the activities. They will introduce the company, what they do. We will proceed in alphabetical order. So I guess if I remember the alphabet well, we'll have Image S, KPMG, Leonardo, NVIDIA, and ST Microelectronics. And then after their 10-minute introduction, then we will have a panel, and then we will ask them some questions. So there was already a poll, and I see that some of you actually have filled in. So I've tried to accommodate for some of your requests and curiosity. So without further ado, we will get started. We'll play a game here. I sit down, and the speaker comes, and I sit down, and then we'll change, because we got only 5 chairs for the 6 of us. So then first one will be Mr. Sergio Perfetti, who will be talking about Image S. So thanks a lot.
Thank you. Okay, good morning to everybody, and nice to meet you to all of you. And posso levare la mascherina? Okay, so my name is Sergio Perfetto, and today I represent Image S. Image S is an Italian company. Is an Italian company that was born almost 30 years ago in the 1994, and here you can see briefly the story of the images during these last 30 years. So the Images is a company that basically, since the beginning, was focused on the machine vision. So the application of machine vision and vision system for the industrial world. You can imagine that in the 1994, the machine vision was at the beginning of the story. So you can imagine that since the beginning, the DNA of the Images was to aim to the innovation, because at that time the machine vision, again, was at the early stage. And as you know, the story of the machine vision now, during these 30 years, demonstrated that the vision of the founders of the company was right. So the application of industrial vision spread across the industrial world, and now the company increased, and we have our headquarters in Mariano Comenze. We have a regional office in Florence, another office in Ancona, who is the reference office for the central south of Italy, and an home office in Frascati. Images basically was born as a distributor for machine vision system. So we are a distributor. We distribute a lot of brands to the industrial world. And as you can imagine, here you have I would say, a very representative portfolio of what we do and what we represent. So, as you know, the machine vision system is composed of components, cameras, lighting system, optics, software, and so on. But I'm sorry. Can I go back? Okay. So of course, we distribute. So our core is to sell system for the industry, and basically all vision system for the industry. But we recognized that during our history that in order to win in this world, we cannot only sell system. What we need to do is to sell and to support the customer in order to be winner in the industry. And in order to do this, we need to support customers in finding the right solution. And this is what we basically are doing now and what we want to invest in. The model, basically the model of images was a winning model, and it was decided to spread the same model across the world. And then the next imaging group was born, and with a total revenue of 35 million, and basically the same model of images that was the business model was born here in Italy, it was spread to other countries in the world. Images was then acquired by funds, which is called Ambienta. It's a big fund of more than 700 million euros. And here you can see that actually you don't see since the beginning was 1994, but you can see that along our history, the increasing of the numbers of our company. And here you can have an idea of how we are structured. If you look at these numbers, you can see that we are distributing companies with 8 salespeople, but 11 technical people. Why a distributing company should have so many technical people in his employees? This is because, again, what we do here and what we sell is components for the machine vision components. So of course, it's complicated things. You can imagine frame grabber, cameras, software, PC, optics, and so on. So we need to support customer. But the main point here that we need to support customers in a vertical solution. So we created a vertical partnership with our suppliers and our customers, and in order to create value add. So, of course, you can see some improvements of our company, but basically our main focus is on supporting customer on feasibility study, testing product, testing the feasibility of application, and so on. So just to give you a couple of samples of where we are really investing money in what we call R&D. R&D for us is, for example, feasibility study. We support customers in doing feasibility studies in deep learning. So deep learning is what we say now is entering the industrial world more and more. But of course, the people from the industry is not really ready for that yet. So they need support. They need people that can drive them in doing the application, understanding the application, and making the application suitable. We hire people and to do this and to somehow create application for customers, because our main goal is to create winning customers, and that can create innovation and can go out there and be innovative. Another, I would say, field where we are investing a lot of time, resources, and money is the hyperspectral imaging. Of course, here we have a demo setup out there that you can stop by and take a look. And of course, here also we are looking at the frontier of the vision system. There is still a lot of things to do in these fields, in deep learning, hyperspectral imaging, but we strongly believe that this is where the world is going and where the innovation is going. And this is why we are investing money. So 30 years ago, we were investing, the company started looking at the machine vision. Today, we continue looking at other technologies, so hyperspectral imaging, deep learning, 3D world, and so on. Okay, so just to give you an overlook of our partnership with companies, again, in the innovation and technology. So I hope it was a very short presentation. Thank you very much. I hope the idea I gave you about images was the right one. Thank you.
Control L to get to full screen. Control L.
Okay, 10 minutes to go.
Okay.
Okay, so thank you very much. My name is Alberto Marocchino, or Alberto Marocchino, depending if you pronounce it with the sort of English accent. And here today I'm representing KPMG Italy, by the way, and I'm trying to give you a vision of what we're doing today with computer vision and what is also our vision toward computer vision. It's sort of a joke of words, but gives you, I would say, quite a good understanding. First of all, what I would like to introduce is, this is very, how can I say, unmovable. So what I try to, first of all, to give you an idea is, you probably are aware of what is KPMG, or probably you heard about KPMG. You're probably familiar with the so-called Big Four companies. The Big Four are basically the 4 largest companies that do auditing in the entire world. And of course, KPMG is one of those. And most of the time, people recognize us for this auditing, how can I say, core business that we do have. Well, actually, KPMG, especially the Italian brand, I'm just putting a stress on the Italian know-how, is not only limited to the audit. We do have, of course, other sort of capabilities and services. And I would say that one of the core services we do offer is the so-called lighthouse, or the data-driven support. As you might be aware, companies today are transiting from a way of thinking that was sort of like intuitive way or making decision to the so-called data-driven decision. So I don't know about your background and your grasp, but when you are a big company, just relying on data is not as simple as it looks. And especially what you have to do, you have to manage processes and internal processes in order to make it happen. This is extremely difficult, I would say. This might be to some of you, I would say, rather intuitive, but it is not. Think about, you need to make a decision. Who's got the data? The data are at the IT. So you need to ask the IT to make an instruction, then it is wrong. And so you cannot make any decision. And maybe you got the press, of maybe the business that want to make any decision on that. So you need to make all this process extremely fluid and efficient. So transiting from, how can I say, a sort of understanding of yourself to make decision to making a data-driven decision, so becoming, I generally say, the new Amazon company is not as simple as it looks. And Lighthouse has basically this sort of skill set and especially role in the market. So supporting companies from the small one to the large one to make make a transition from a more traditional way to do, let's say, business to a modern one. And this, of course, goes with the introduction of artificial intelligence in a very wide spectrum, and of course, also computer vision. We are an international brand. So Lighthouse is basically everywhere in the world, in every country, and we are a network. So KPMG is in every country. Every country has more or less a lighthouse, and Italian lighthouse is connected with the rest of the world. And of course, by doing that, we try to expand our knowledge and our network. So that means we have connection with universities for specific projects, or just by enriching ourselves and our way of thinking, and especially getting new ideas that are coming out from the research and trying to convert it into, let's say, product, or I would say, I would rather use the word value. And we are, I would say, about more than 4,000 people. So the slide says about 4,500. I think we are reaching almost the 5,000 people nowadays. So it's quite a large company, and you're not relying, how can I say, on a firm, you're relying on a network that is basically worldwide connected. So it's, in my opinion, an extremely added value for generally a company. So why computer vision? So why I'm here today, why KPMG is standing here talking to you. And the vision that we do have is that we translated into, for KPMG, computer vision is the next big wave. So I will stress in the next slide this idea, but if you see, it's not bolded here, but computer vision, it's only 11% of the so-called artificial intelligence market. So every application that can be categorized under artificial intelligence mostly goes, let's say 90%, under the so-called structured data. So the computer vision is only limited to about 10, 11%. So it's an extremely low market to the potentiality that it can offer today. For us, in order to, how can I say, surf this wave, this new coming important wave, you need 4 pillars. You need computer power, you need cameras, skill set, and framework, okay? So the boost that we have today is because the computer power is, how can I say, good enough. It's coming to the limit in which it can be democratized. I generally use this word. Democratize means a capillary use. So it doesn't mean that you need to be a big, large company with a lot of money to invest in specific technologies. Now you can afford it. You can use the cloud, you can use services, and the price that you can pay is extremely limited. And open source is also boosting this. So this is an extremely important pillar in the democratization and use of artificial intelligence, especially in computer vision, at a capillary level. Of course, the lowering of the cost of the computer power has also lowered the cost of the technology. So cameras are extremely accessible, you can use that. Where KPMG is actually relying, we are not manufacturing, so we're not producing, of course, cameras, and we are not a vendor of cloud. What we're focusing nowadays is on the skill set, so preparing the people for the next big wave, and especially looking for talented people to join the Lighthouse in order to get ready for the new, how can I say, solution. And the other aspect is that as a company worldwide, we are developing our solution. So we have our framework. We develop model, and especially we got specific framework that we generally keep on updating in order to offer specific services already ready to use. Now, this market, as I said, it's huge. So I would say this is an extensive slide where I try to summarize at least 8 of the most important applications of computer vision. And I've also mentioned 2 important things, that is the one that I was saying earlier. So the market that we do have in Italy at present for computer vision is only about 11%. So there's a huge amount of room for this specific technology. The other important fact is that if you see the difference between 2021 and 2022, it's about 40% more, 41% more. So people finally are getting to understand that this technology are at the mature level that we can actually start using that. So as a way to read this slide is also, I think it's pretty clear, but let me stress it. We do have our capabilities. So the light gray is where we do not have so much experience, or better, where we haven't applied yet our technology. I'm thinking, for example, to the aerospace environment or the agriculture, but retails, automotive, smart cities, manufacturing, we do have our solution, and we are currently working in this field by having, I would say, astonishing results, and we are especially boosting this next wave that is coming. As a final slide, what I would like to make is 4 specific points. So I've told you who we are, KPMG Lighthouse. I've told you that is the next big wave that is coming. The democratization is boosting this solution and, of course, the lowering of prices. I've told you where we are good at, but especially the market that is still unexploitable. I can tell you the 4 pillars that we're using to achieve all these results. And the first pillar I'd like to stress is the digital translator. So we believe that to adapt this solution, you need people that are not extremely technical. You need people that have a business understanding as well as a technological understanding. Just to mention you, I think you're familiar with the Elon Musk tweet that came out about a couple of weeks ago, in which he says, for me, a good manager is a person that can do the same job as a trainee, but can do it much, much faster and much, much better. Exactly. So we need people that can do the work much faster, much better, but at the same time, they understand a different sort of language. That is the business language. So they can find the right spot in order to introduce technology. This, again, seems extremely simple. At an industrial level, it has some, I can say, drawbacks. So you need specific figures. This is where we are training our new consultant to be. So digital translation. Technology might be extremely difficult. European community is pushing a lot about ethics. I would also say that you can use a lot of models, but you can have, I don't know, 99% of accuracy, but at 1% might be huge, especially if you talk about pharmaceutical applications. So pitiful are extremely important. And as KPMG, we do have our protocols in order to avoid that, and we support companies in developing protocols in order to make sure that the models are, let's say, robust enough, meaning in an industrial level. Of course, we do, as I said, our models and technologies. So we are scouting for new technologies. We are helping the adoption of new technology, also breaking news. So something that is coming out from the market, we evaluate. We support them in understanding if these are right for the company. There's no good and bad technologies. There's generally good and right technology or not right technology for a given environment. And of course, the last one that is, I would say, where our also part of the business goes is the strategy and governance. If you are a large company, having a lot of data scientists that work together is not as simple as it looks. Organizing people that are smart and they have, how can I say, enough maturity to understand where to go is extremely good. But you need to keep all the people working together toward a common goal. So you need sort of, I generally say a motivator, that is a very casual word, but it gives you an idea. So you need a new generation of manager and people that have an understanding of the entire data life cycle that can support in this transition. So these are the 4 pillars that we generally use in order to boost, how can I say, adoption of the technology and where we believe we are making a difference into the market. Thank you so much.
Good afternoon. My name is Alessandro Nicolosi. Actually, I'm the responsible of artificial intelligence area of Leonardo Labs. It's a pleasure to be here with you. So we will talk about briefly about Leonardo Labs. The Leonardo Labs are technology incubators that intended to support the long-term research of Leonardo. So to support the research and development of the Leonardo products and business. And it's an initiative that is started since 2 years ago. And now all the labs are in total 11 in Italy and something also in the USA. And in this lab we have briefly 80 researchers that works in many areas of research like robotics, big data, digital twins, simulations, APC, and of course, artificial intelligence. Today, we will focus on the artificial intelligence area. In general, we have 6 labs of artificial intelligence. The central labs is in Genoa, and the other one are in Rome and in the USA. We have actually 24 research fellows, that is increasing to 35, and 25 active projects, research projects of many areas like computer vision is the best one, and 7 in natural language processing, and the rest are in time series analysis, audio signal processing, and 2 in reinforcement learning. We also have 15 industrial PhD with the main best university of Italy that we just found to work together in some part of the research. In Leonardo, we have also an asset that is the Da Vinci One, is a supercomputer. And in Da Vinci we have 300 GPU NVIDIA and A100 and 56 Intel Xenon Platinum CPU. We use it to train, obviously, the neural network and also for advanced simulations. Okay, I explained briefly the area of artificial intelligence. The research area is divided in 4 main streams. The first one is the core AI, that is general purpose study of paradigm, learning paradigm that the goal is to solve a general purpose problem in the field of deep learning and machine learning. We will see after. Another one, the trustworthy AI, that will go deep after this slide. The domain based that is focused on the deep domain of, for example, computer vision and deep application of our company. And the efficient AI that just translated this model to low power computing hardware. So for the core AI, we have briefly 6 mainly problems to solve in this research area. The first one is the small data problem, because in the industrial world we always have many data that are unsupervised and less data that are supervised for some reason of time, of cost, and other type of reason. And so we want to study all the technology that can solve this problem, like self-supervised learning, meta-learning, few-shot learning, one-shot learning, etc. So this is one of the main area that is related also to another main area that is the synthetic to real. So as Leonardo, we have many simulators because we work many with also the training, and we have many simulators, open source and also private. And with this, we can generate a huge amount of data that are free labeled. And so the question is, can we use this data to train our neural network and transfer it to the real domain? We think that this will be the future also with the metaverse in general, like concept, because we are going to photorealistics, always more photorealistic simulators that can be used to train the neural network and just transfer to the real domain. Another problem is the generative learning that we use in transversal manner in all the fields, because we can use to generate data, synthetic data, or support domain adaptation or other kind of algorithm. And one of the challenge that we want to study deeply is the continuous learning. Continuous learning, like we said also before with the other people, in general, to train a neural network in an incremental manner. So without the retraining in all the data set that we just stated before. And the reinforcement learning is very important for the decision support system, because we have many systems where we have to support the pilot, I don't know, or the other agent to take or make our decision. In this manner, we are studying some technology in the offline deep learning because we have sometimes many data acquired from some sensors and we want to exploit this data. The other best pillar that you want to solve is the trustworthy AI. As industry, Leonardo, we think that is not enough one or two performance metrics to characterize a model. So to have a very safe model, if you want to deploy a model in a product and you want to satisfy some requirements, we have to understand how to work, how this model works. And so one of the best things is the interpretable AI. So you want to interpret the model, the decision model that we are deploying. Another part of this research is the robustness of the model, because we want the same characteristic if we perturb the input. And one of the big challenges is the certified AI. How can we certify a deep learning, a data-driven algorithm with some techniques? What means certified? What means all this stuff also with ethical and legal studies. So it is one of the best pillars that you want to solve in Leonardo. For this part, I go fast because we always apply these two pillars to the other domain that are more deep. So sorry, is an error, is computer vision, natural language processing, time series analysis, audio and signal analysis, general, and decision support system. This is the domain-based AI. And after, we study also model compression, neural architecture search, and also something like neural network, like spiking neural network applied to neuromorphic device, because we think that this may be the future of the low-power devices in this direction. We work with, in general, as this. We take the general research, the public research, we study the research, we study new approaches, new architecture, new ideas. So the goal of Leonardo Labs is to be present in the research world. So we want to produce papers, patents, and obviously we have to apply this, all the technology that we create in some business related problem of Leonardo. The input are the Leonardo itself, the European research projects, external projects like other clients, I don't know, Guardia di Finanza, Protezione Civile, Carabinieri. And also we do challenge online like Kaggle, iCrowd, Zindi, Coding Game, etc. Because sometimes some technology that we use to solve this challenge can be very useful to our product, like, I don't know, multi-object tracking and other very nice challenges. I finish with this slide. We use DaVinci to train our neural network. So one of the main things is to gather public and private dataset. The private dataset obviously are the dataset that is generated by Leonardo sensors, imaging, hyperspectral images, infrared, etc. And after, the output is like GitHub banner. So we have a paper, a guide to the project, a model that is trained, and the code of the project. So it's very, very simple. And this code is it's public to all the division, all the Leonardo group. So we just help Leonardo internally with this. Thank you for your attention.
Okay, while I look for the presentation, and be sure that also the video I like to start with works. I like to say buongiorno, everyone. It was good to see some people that I haven't seen for a couple of years because of COVID, people that I met last night. There is also a group of students, PhD students from Poland. So let me go through a very fast introduction to NVIDIA. And let's see if the video works.
smallest particles. And the infinite possibilities of the universe. I am a guardian, protecting us on all of our journeys. And ensuring our most precious passengers make it home safely. I am a healer, searching for hidden threats in every cell. And delivering precise care with every breath. I am a helper, taking on complex tasks in the most challenging environments and giving our crops room to grow. I am a creator, transforming the very fabric of our everyday lives and using the creative DNA of the masters to inspire a new generation of art. I am a learner, taking just minutes to discover how to crawl, walk, and stand on my own. I am a storyteller, giving emotion to words. Und die Sprachbarrieren abzubauen. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
So trying to fit what NVIDIA's done in the latest 10 years in terms of AI in 10 minutes is pretty tough. So I decided to start with this video that gives a view of an handful of use cases among the several hundreds, I would say several thousands, that NVIDIA engineers, our ecosystem, our end user have been developing and deploying in production over the last 10 years, the latest 10 years. In the 10 years, NVIDIA got a key role in terms of AI, and since then we are starting investing heavily, mostly on research, most on big research labs all over the world and universities. And since the very beginning, it was pretty clear that this is a computational science that requires proper infrastructure and the software stack in order to go over the threshold and reach this kind of result. Even recently, Gartner, almost 10 years later, mentioned that half of the AI projects fails to get in production because of the complexity of the infrastructure. We indeed faced those problems several years ago. We decided to invest in our center of excellence, in building data center, in having our own supercomputing. The latest implementation of which is called Selene, which is, I guess, is still in the top 10. And we really behave as a consultant from that point of view with our end user. We are going to talk about the full stack approach we took in the next slide, but let me mention a few things about NVIDIA that maybe more than what you see on screen are relevant for the meeting today. And something our CEO is pretty proud of. The company has around 20,000 people, employees. The vast majority of them are engineers. We think about 80% of them. And 50% of these 80% are software engineers. So all the work we are doing internally is pretty massive. All the tools I'm going to talk in these few minutes left are already developed for them, and for all our customers worldwide. Other points that are pretty important to underline, how important for us is research and connection with university, and have technology transfer from universities and enterprise is the number of developers, 3 million worldwide. It is a huge ecosystem of partners. Only startup, they are around 10,000 worldwide. There are now over 2,700 applications that are accelerated. And we developed between SDKs and pre-trained model over 450 of them. If you think that a few months back were around 200, we are really growing very, very fast. Everything really to support AI development at different level, depending on the know-how among the customer. I mentioned earlier, full stack approach is pretty much divided in 3 areas, let's say 4. At the bottom, you see the hardware part. This is what NVIDIA is recognized by default. It's really an end-to-end, so it goes from data center, CPU, GPU, DPU. It arrives also to embedded products for the edge. Then we have a system software that is really very wide. I'm never going to be able to go through it today. And everything converges in 3 areas, which are high-performance computing, AI, and what we call Omniverse, which is a platform for 3D simulation and design collaboration. And then there is an additional layer of application, and this really took a lot of efforts from our side, a lot of resources and research with universities and with key accounts. So I decided to, there are 450. I don't have time to go through that. I will never be able to even start going through 450 of them, but these are pretty important in this phase. We have for data scientists, Rapid, mostly used for data preparation. We have Spark. We have Co-opt for route optimization. Then we have a growing of the recommendation model. Speech and vision, are really 2 bulks of the development. What is in this slide is Riva, text-to-speech, speech-to-text. Tau is transfer learning SDKs, so we develop a lot of high-quality pre-trained model in order to facilitate the work to our users. Deepstream is typical for smart spaces. Then we have Triton, inference servers, and then we have NLP. NLP is growing pretty fast. In Spain, we have done a huge job with Barcelona Supercomputing Center. Clearly, it's useful for Spain, but also for Latin America. And this is used in many verticals, from financial for know your customer. It is used in defense, etc. By the way, Alessandro mentioned the GPUs inside DaVinci 1 and beyond that. Indeed, there is a lot of work and communication on AI project with Carlo Cavazzoni, Alessandro Massa. And this is the 2 more slides. This is related to Omniverse. This is really great. There is a great explosion in this area, impacts multiple areas. It is something that is extremely flexible. And we are, let me say it this way, we are growing a list of users that are interested in being project on this kind of task. Worldwide is pretty known, the one about digital twin of BMW fab. But there are really requests in completely different areas. Recently, there was a discussion about digital twin of magnetic containment for nuclear fusion. So the potential and the flexibility is extremely wide. And this is my last slide, discussing about the relationship, the engagement, and the importance for us to work with universities and have this technology transfer tool into the enterprise. In Italy, we have something that is pretty important, is a joint center with CINI and Cineca. I'd like Giuseppe to stand up a little bit, because if there is interest in collaboration with NVIDIA in Italy, this may be the right way to start. And Giuseppe Fiammeni is the leader of this team that is growing. We also have Andrea in the room. We can leverage on Cineca. The number of projects is growing. We are hiring, so our intention is to grow even faster. I would say one thing to close. maybe I'm going to, it's finished. I need to say ciao, thanks.
Okay, thank you. Good afternoon. I am Antonio Guemi from ST Microelectronics, and with this presentation, I want to introduce my company and give you a brief overview of our activity on artificial intelligence at the deep edge. First, let's me say that ST Microelectronics is one of the world's largest semiconductor companies, and among these numbers, I want to highlight that it has 48,000 employees, and of which more than 8,000 are working on R&D teams. This map shows how our offices are located in the world. We cover quite all the planet. And our mission, our vision is that we want to be present in any context where microelectronics can make a positive contribution to the people's life. So we are present in different markets, from automotive to making drivers safer, and also industry, and of course on the world of Internet of Things. Let's moving on the main topic that is artificial intelligence on the deep edge. We can have several approaches to artificial intelligence. One is decentralized approach. This means that sensors collect data and through sensor node and the gateways, they are sent to a cloud where the intelligence capability are. And this approach, of course, gives us some advantage because we have quite a limited processing power, and it's very simple to update a model. But on the other side, we have low responsiveness, high bandwidth requirement, and also there is some risks in terms of privacy because the data travels along several networks. And moreover, it is also an energy-consuming approach. So one trend is to move toward the edge processing. When the artificial intelligence capabilities are on the gateway that becomes smart gateway, we speak about artificial intelligence on the edge. When are the sensors itself that are able not only to collect the data, but also to process them autonomously, we speak about deep edge. So this approach is quite better respect to the previous one because we reduce the bandwidth, because it's not necessary to send the data to the cloud to be processed, and so the responsiveness is faster. And also we have no more privacy problem because the data are processed and stored locally. But there is also some drawback because it's difficult to update the models in a distributed way. But the trend is that global shipment of deep edge AI devices will reach 2.5 billion by 2030. So this is why there is a growing community and ecosystem of deep edge AI technologies focusing on standalone solution also for embedded devices. And this is our most important challenge. In fact, we provide several solutions with different AI complexities. Starting from the bottom layer, we have smart sensors that are advanced sensors that can be used alone or joined with our microcontroller and microprocessor. And currently in these devices, the artificial intelligence capability are enabled with machine learning core and finite state machine. Moving to the upper layer, we have the sensor nodes and points, where we use not only the sensor, but also microcontrollers with embedded memories and peripherals. So here we can also enable machine learning solution, and we also provide a software suite that make this very simple, named Nano Edge AI Studio, that is focused on machine learning solution. And also we developed the STM32Cube.ai tool that is able to automatically optimize artificial neural networks, speed up significantly the process. Moving on the top layer, we can use also microprocessors. We have the STM32-bit family that is able to provide Linux solution for TensorFlow, and again, we exploit our software suite. This is an example of how this kind of framework helps us to achieve solutions in a quick way. This is a people counting sensor that we developed in collaboration with Schneider Electronic, and it finds application on queue monitoring and affluence monitoring and social distance monitoring. In this case, the automated neural network inference run on the STM32H7 microcontroller. How we achieved this result? Well, the first step is to find the best solution and the best neural network to solve the problem. But since STM32Cube.ai enabling makes simple to convert this solution and optimize it depending on the target hardware that is our hardware. The customer can focus on the application, and this allows to achieve a solution that can run on the STM32 quite easily. So we propose a quite complete set of solution. I mean, I can define this a complete framework, because we start from the hardware, but we also provide AI software and ecosystem. I already described, but I want also to mention the function packs that are included in our software, that are implemented use case that can be customized by the customers, and we also provide AI design center for the customer that want to design their own solution. So these are our reference to join ST in several social networks to find more details. And of course, there is also the official site with any information about both hardware and software solutions. That's all. Thank you for your attention.
E poi ne vedo un altro là. Questi due, no? Ok, tre. Okay, so, well, first of all, let me thank again the speakers, the companies, and the people actually here, the colleagues that accepted to say now to play the game, so to participate in the panel discussion and to be out of their comfort zone, out of a presentation that they prepared. So I prepared some questions, and I will try to raise some discussion on some of these points. The purpose of this is to say, put the challenges on the table and ask the companies their opinion, which may be different from what researchers, academics in general have. Just to set the stage, well, can you see the presentation? Okay, great. Just to set the stage, I'll start with a claim of somebody that counts. So I'll take the claim of one of the principal scientists in DeepMind. I'm sure you heard about DeepMind, and probably a lot of you heard about Nando de Freitas. So about 10 days ago, he claimed the game is over, and probably speaking about the academic game, or to some extent research on models. It's about making these models bigger, safer, compute efficient, faster at sampling, smarter memory, more modalities, innovative data on offline, right? So this is, I found this might be a motivation to get started on a panel with industry, right? From this point on, a lot of these topics are actually industrial topics. So with this in mind, so this model is called Gato and is ingesting every task you may think of. So 3D reconstruction, reinforcement learning, so learning to move, and natural language processing, everything. So with this in mind, I'll raise some questions, and I will also say appoint somebody to get the answer started, say if you're comfortable with, then of course the discussion can proceed. One of the first questions that I think speaking with you was raised the most is the current AI enough for my industry, or what is missing? So here I would propose we start from Sergio Perfetto from Images, and then of course everybody feel free to come in.
Okay, thank you very much for your question. Actually, the answer that I can give you is based on our focus, which is the machine vision. Again, what we do is machine vision, and all of our application of AI are on machine vision for industrial. So what is missing? The AI for machine vision is now seen as a very innovative technique and technology. And if you think about the industry, so we are talking about automation industry. The automation industry is conservative somehow industry. What is still missing is the education of people working in the automation, and acquire the concept of AI, deep learning. And which is not very easy if you think about the conference today. It is something that is still on the research table, right? So we are, so the world is investing money to make this technology available for everybody, but there are still, some steps to do. And this is why we are here, and Images is investing resources in this, because our customers still need support on this. Some of them are, most of them are, I would say, independent when we talk about traditional machine vision, but when we step on the AI, there is still a step to do.
Okay, a very good point, I guess. So it's sort of missing is the people. That's a very good answer. Anyone wants to add to this something that is more about the topic, for example? Any addition to this? Any of you feels like?
If AI at this stage is enough,
Yeah.
that's the question. I would say no.
Nando de Freitas says no.
Sorry?
I mean, I showed this.
No,
so
no, it's clear.
This is a no.
No,
I think most of the people on this side of the stage would disagree.
I mean,
that's their job.
I think that it depends a lot on the industry and the perception of AI inside this company. If you want to patch some problems using solution already available in the market, at this point, especially on computer vision, you can find many with very good accuracy. If you want to make a step further, and AI becoming a differentiator for the company, excel in that area, we are only at the beginning. Plus, consider the growth of topologies that we have added during the recent years. Consider transformers, how big they are, and now much less labeling they need. Consider autonomous driving. There was some announcement about level 3. We need to ride to level 5. So really, depending on the industry, that's really the big question mark. We might be almost there if you just need to patch something, or just at the beginning if you really base your future business also on AI. And there are a lot of customers doing that.
Very good answer. So, yeah. I would also like to add something to this. So it's, and this connects. So maybe I just read it out and then Alberto, I'll leave the word to you. So what missing bits of AI should I develop in-house, and what should universities address? This is also just to make the distinction, what industry is expecting to have as AI, and how some universities should contribute.
Yeah, so what I want to add is AI enough, you ask, and of course everyone said no, and I would say we can see it in numbers. Most of the most senior people didn't have a PhD because there was no PhD in Italy at the time. You were probably, today you're 50. And as you see, the number of PhDs is increasing, so that means that the research is needed everywhere. But this is, let me say, this is just half of the medal. You're missing that whatever you're doing has to be industrialized. And making the step forward is not only technological, it's the change of mind. Most of the time you need to wait for, how can I say, an epoch to hand and having fresh mind in a company in order to start it. Why startups are making better than large companies? Because startups are made by freshman people that do not have all the limitations that big companies have. So what is missing is also missing the change of management or change of mindset. And this is much harder, in my opinion, than innovating sometimes. Because innovation can start from a very, how can I say, limited number of people with a bright idea. And if the idea is bright enough, it can be seeded. If you're in a large company and you need to change the process, that's extremely hard. So making sure that the AI solution is bringing value, that is not extremely easy. I call it on social the Panama Channel problem. It's very easy to define the cost of the Panama Channel. I mean, if you take a boat and it has to go all around South America, you know how much fuel it's going to take and how much of salary you need to pay, to make it 3 weeks trip. If you cut, you know how much you can charge a boat. That's extremely easy. In artificial intelligence, things are not so easy. So if you're good enough to find your Panama Channel, you know where you can make money, add more, or you know how much value you're adding to a company, value in general, not only money, value. This is not very easy. So on, I would say, an industrial standpoint, there's a lot of missing in terms of technology and in terms, of course, of change mindset. So if you're asking what are university missing, there's probably some technical parts, but I think there's probably more, how can I say, educated people on this topic. What I might say that I want to stress, was one of my points, was two aspects that are not very technical, but when you get to large companies, they become crucial. One is a problem of digital translation. When you go to a company, everything you do is related to value. Remember, value, at least in the most, how can I say, modern way, is not related to money, it's value, right? Simpler process, people that are not, doing repetitive tasks and so on. This is not very easy to find. A young person that is a freshman might be also have a PhD to understand where this is actually bringing value. And the second aspect is most of the time when you deal with data, you're dealing with personal data. So this morning, the very first talk, the invitation lecture was excellent, and the speaker mentioned the mother that was asking about privacy. Well, when you do have to deal with cameras taking picture of people, there are privacy issues. Of course, you can overcome them, but it's not as simple as just putting a camera and recording people movement in real life. So these aspects are not as technical as they are, but is where people entering in the industry, they're normally facing the most difficult part in getting the mindset to the fact that a larger environment has got, how can I say, tighter boundaries. Research has the freedom to do certain things. In the company, sometimes you've got more limited room. And the fact that you might be aware of this limitation might help you in addressing certainly problem in a much, how can I say, industrial standpoint. These are some limits, but also some advantages at the end.
Thanks. I think this takes us to the next question I actually had in mind, which is what are the challenges of AI innovation transfer and what strategy to take AI models to production? I think here, maybe Alberto, you can add some comments if you want on this digital translator, but I guess this is a challenge that probably many of you have faced, right? The moment you want to deploy this and make it a product, what is the biggest challenge? What can you share with the audience about that?
I could say, okay. Now, for the last question, I think that the game is not over. In general, very, very fast, because I think that we need to understand another way to learn. Okay, it is not enough. Also in multimodal manner, also with a very strong representation that generalize well, because we miss something that is related with consciousness and other stuff like is proven by biological system that are very complex. And I close this for this mind. For this new question, I think that I will think about it. I pass the question to another.
Thanks for defending the academic point of view. It's not over.
I have to think good.
Go ahead.
Okay, so again, for the industrialization, to bring the AI to the industry, what is missing? I think that there are still a step that must be done in order to really have some industrialized product and solve application for the industrial world. I'm talking about, again, for the machine vision world. The potential is huge because there are still a lot of applications that were left behind because the traditional algorithms, traditional technology was not able to solve it. So there are still huge application in industry. Just to make a couple of examples, there are still a lot of industrial process where they're still controlled by human eye, but it's a huge number of applications like this. So the potential is very big, but we need to solve some step. In my opinion, the step that must be solved is to speed up the teaching process. Just to make a couple of examples, I don't want to be very specific, but speed up the teaching process. So the teaching in order to let the customer teaching properly in networks. This is one example of where the process must be improved in order to make it industrialized. Or, for example, speed up in some cases the inference time. If you think about the industrial process, you must be fast. So inference time must be fast as well. So we are at the beginning. So I agree with you. We are at the beginning. The potential is huge, and the contribution of the research world, I think, is very, very important for this reason.
Thank you. Certainly for the computational part, I think there's a lot of research that can help.
Yeah, I mean, I think I covered already a little bit this during my speech. Indeed, it's pretty difficult. It's not trivial at all. It's extremely challenging. We faced this years ago, and we could find a solution for that. As I said, we started with these data centers, supercomputing, the right infrastructure, because in order to go beyond the threshold of making AI a bulk for a company, you need to have, at the sentence from Giuseppe is really, this is computational science. Here you need an infrastructure and a full stack, and this is exactly what we did, with the point of taking all of this know-how and giving it to the end users. So when I was showing the full stack, the idea is really to give this know-how, and I think 90% of it is completely free on a repository online called NGC, really to help people starting, or if they're already at a certain level, speed up the process, pre-trained model, transfer learning, SDKs. The idea is really to help the end user to approach AI in the right way and avoid the mistakes we have done at the beginning. And we keep doing, by the way, but at least most of them were solved.
Do you want to comment? Please go ahead.
No, I just want to answer to the question from ST point of view. In AI, the algorithms are always a big challenge, and we focus on solution for embedded devices. We know that in the near future, devices will be more connected, and so the solutions and AI solution will have to be also more secure, more connected, and more intelligent. But despite the progress, it's very difficult to deploy a pure software solution for embedded device. So there are different strategies that we can follow to do this. One is to exploit the technology evolution, for example, with the memory computing. But the way we are following is to develop also ad hoc hardware accelerator for specific AI tasks. In the recent Capital Market Days, STM announced the STM32 MCU that includes the N6 that includes the neural hardware accelerator that has state-of-the-art performance in terms of both inference per watt and inference per dollars. So this is a big challenge, and also from the software point of view, we, as I described briefly in my presentation, we develop also tools to make it easier for the user to move from a pure software solution to an hardware accelerator solution that takes in account also the target hardware.
I mean, if I may actually, because
I want to move on.
I want to bring one more question to to the screen because I think, I mean, both Francesco and Antonio in the presentation, they mentioned ecosystem. So Alberto, maybe if you want to comment on this as well, or the previous, just go on. But here, I also want to cast another question, which is, does the success of AI require an ecosystem? So you mentioned it's just not just one company, maybe not just one task. Is there any gap in this ecosystem that certainly needs to be filled? Or do you have a feeling about that?
So I'm making, let's say, a general comment that my answer the previous and this question, and probably brings to the table another, I can say, let's say, an interesting topic. I generally refer to the data scientist as a Renaissance person. You know, when you are in the Renaissance, if you are a person that has a knowledge, like Leonardo, you know, you are not a painter, you're not a sculptor, you're not a scientist, you are all of the things together. So data scientist today, at least in my perception, what I can see, is a person that deals with data, structure, unstructured. Sometimes, most of the time, he has to prepare the data. If you're writing the model, you need to understand how to prepare your own data. You need to know a bit of the infrastructure, because if they ask you what sort of infrastructure you need to give indication. So it's not answering the previous and this question, but is adding an extra point, and is also connecting where is probably university need to add. The people that we have today are very flexible, are very modern, they are solving an entire problem. But this brings another point of view, is that you're always doing new stuff. This is very challenging, very motivating, but at the same time, you need always to learn new stuff. There's nothing that is industrialized, and when something is, how can I say, a standard, it's most boring, but you know exactly what you have to do. So you got less bottlenecks, you know where to move. So the question that I'm bringing to answer this question and to add extra challenge to the question is, what is a data scientist, and what's the limit of the knowledge that a data scientist needs to have? Is there a straight, how can I say, distinction between a data engineer, a data scientist, and eventually the one we call the machine learning engineer, so the person that sort of make the model that has been prototyped by a data scientist industrial, so he knows maybe more about the technology and less about the algorithm. So I guess it's more than a question than an answer, but somehow it points out some interesting point.
Yeah, very nice. Is this the role of a spin-off of a university? Giovanni is asking.
It might be, in my opinion. But what I think, so I have a very bad opinion about startups. If I have to be completely frank with you, startups are...
Please use the microphone for the sake of those listening on the internet.
Just startups because there are ideas. You have a lab with many people working on focusing on a topic, let's say wearable vision, right? And you bring part of that lab and you move forward transferring what you have built as prototype versus product, more efficient. As you said, you said before, which we need something connections. So in this moment, what I see is that we are training new people, new generations that you guys will bring aboard. But there are groups already working on technologies, and probably they are working more with abroad companies than in Italy. So my question is, what could be the role of startups in Italy? Because there are many now in our community, in our computer vision community. Also in this room, there are many groups that start up, and that could be a chance probably from big groups to take people all together, formed already. It's not just one point you put there, but people that you trained many years, which work already together. It could be something useful.
No, absolutely. As I was saying, you talk about spin-offs and startups. Yes, they have, in my opinion, two completely different roles. And as I was saying, for startups, I do have like the entire love of my life, and I completely think I failed my life when I was 28, just got to my PhD, and there were startups in California asking for me, and I decided to stay in Italy. You know, what a good idea, instead of going to the Silicon Valley, becoming a billionaire probably. So, whatever. Now, the point is, sometimes I look at startups, and I think that big companies have or succeeded or failed. The point is, for many years when I was younger, big companies were doing R&D. So they were developing new technologies. So if you want to do research in a company, you were in an R&D group. Now somehow they have externalized. That means that they are not even putting money. So they are getting the startups when they know that they are into the market. So they are leveraging on this capability of the people, and they're just buying it. Of course, they are making a few people rich, but they are not investing. So this is something I always get puzzled in an ethical point of view. But if you're thinking about the gap, that's probably the exact gap where I would say university or research center, more in general, can really make the difference, because you've trained the people and you're just making the connection to the real world. Probably the missing gap, in my opinion, is that there is no, at the moment, connection when the startups grow. So you got an idea. It's very hard, in my vision of the market, this is where we are helping startups, to find a connection with a company. So, oh, that's a good idea. Let me put, I don't know, 100K just to get you started, right? They normally have to go through a series of rounds, and when they have a sort of maturity, they start the so-called scale-up procedure. So when they're in the scale-up, so the big company in that moment is very interested. In my opinion, you have already failed, because you could buy the same company for half of the price 2 years before, and you can help it grow in the right way. But that's exactly the missing gap. And the good thing about that, apart the bad thing that I said earlier on, is the exact other aspect, is you allow the best people to emerge. So it's not R&D, in which sometimes, things can get a bit fuzzy because some researcher wants to do some more experimental thing. If you start the startup, you need to reach certain goals. So you have your KPIs, so you're already in an industrial way. You got goals and you got times, and you need to reach them. If you're a university, the good things about spin-off is that this moment is a bit diluted. So you got more time to fail and to get to the right point in the right time. And yeah, that's the exact point in time and space in Italy where you want to have a startup, by the way. So this is what I could see from my analysis. If you have an idea, this is the moment you have to start your startup in Italy.
You got a consultancy from KPMG for free. Any other comments on this topic?
I'll try to be short, since I took already too much. I mean, we have this inception program with the 10,000 startup. So definitely our approach as NVIDIA is big problems that need to be approached with resources, and the ecosystem can make a big difference. We have many of these 10,000 in Europe. Maybe there are not enough in this program from Italy and Spain, since I cover also Spain and Portugal. You are very welcome, guys. So I really would like to have more startups, Italian, to be part of this program. Also because NVIDIA can help them to scale abroad. And this is something that is already happening in many verticals. One of them is really related to the smart spaces. So this is really our way to operate in that specific vertical and growing. So the answer is yes.
So thank you so much. I think advertising this is a great pro for the community. No worries. I mean, we don't have to go over all of the questions. So I'll put on the next one, which is going to go back to a little bit more technical, if you want. But I know that some of you touched upon this, right? So Sergio, I think Alessandro also touched upon that. The question is, well, data and competitivity lies in data to some extent. I think this concept, I think so far didn't emerge. And I would like to say, get your bet. What would you bet on? Synthetic words, pre-trained models, that could also be a business model, or, for example, investing in, harvesting massive quantities of unlabeled data and then use self-supervised learning to just make sense out of data from the data structure itself. Any of you?
I think all of three.
But some of them have got an issue. For example, if you take a pre-trained model, you don't know what's inside, right? The typical kind of potential harm.
Exactly, but I think that for now the technology is too much data-driven, so we need too much data. This is the way, is why I said before that we are not ready for true intelligence, the general intelligence. So for now, the only way that we should do, and we see also with these new technologies like, I don't know, Flamingo, Gato, etc., is to have many data and many multi-domain data also. So, in my opinion, synthetic data, if you have a very photorealistic system, could be the future and will change the way to do the deep learning, in my opinion. But of course, we need also huge computational resources, because more data imply that you need to more training, so more computational resource. So just this.
Well, I think in supervised learning, synthetic data can help to speed up the process. It has been estimated that data scientists spend more than 70% of their time to develop a model during the phase of acquisition, annotation, and augmentation of the data. So synthetic data that are not acquired but are generated can be speed up this process, because we have no issue from the privacy point of view, because we have no personal data to remove after generation, and we can also address a very specific use case in order to make the model able to generalize on never seen data. But I think that the best solution is to use both real data and synthetic data.
Thank you. And moving on this topic, because I think data is really one thing where I would like to make a second, argument. So here, the director of the EU Data Directorate said we need to populate data spaces. And the managing director of TNO, which is an applied science institute, said that the main challenge is to unify data spaces across sectors, countries, and technology. Interoperability is the key. And here, what they really mean is starting to collect data EU-wide, not only from, say, health, but also from finance, manufacturing, mobility, anything, putting everything together. And there are already some EU-funded projects, like, for example, the Gaia-X, that is trying to develop some sort of German data hub, right? So this calls for, say, data sharing, and of course, this idea of across sectors. What are your comments on that? So it's, I'm looking at Alberto because I think he might be the person more, say, with more visibility of this across sectors.
Yeah, maybe. I'm sure also the other speakers have. Let's say probably a couple of things. The first is there's a brilliant English, I think it's English-American expression that says to distinguish the signal from the noise. So it means when you have a lot of data, you need to cherry-pick the signal that gives you the value. And with this explosion of artificial intelligence, meaning you can pick the right external information that gives you value. It's like, you know, to predict the stock option. You need the history of the stock option price, because if a company is doing good, of course it's doing good. If you look at Microsoft, it kept on growing in the last 20 years. So, by the same time, what you probably need is extra information, like how's the market in general is going, and if there's any acquisition, so news, basically. The point I'm trying to make is these projects are indeed the future, because artificial intelligence doesn't need at that point to be seeded with specific information, but it needs to be able to down select a lot of information and just pick the right one. And this is a bit commercial as an information, but we try to do the same as KPMG. When you try to make, for example, forecasting prediction, this is one of our solutions. So you need to know how many products you will sell in 6 months or something like that. It is very important to know how much of your product you have sold in the past, but you also need to know what the population is thinking about you. Just think about the COVID-19 situation. The fact that the virus was spreading, there could be another lockdown or restriction, could change, the overall. And we developed, similarly, of course, European communities coming with, I would say, a massive approach, the so-called signals repository. So the fact that you can sort of uniform, you have, I call it a big cube of information, you can move multidimensional 1 point, give you a sort of boost in the information you can have, and artificial intelligence at that point become extremely important in supporting you. The limit of those, in my opinion, for certain application is the explainability of some model that might be extremely important in some situation.
Okay, I think I would then move to the last question because we're already over time, but I think I also wanted to raise this. And since you say that, the last question that, I would like to put here on the table is, can we get started using AI? Because it seems like we already did. There's already a lot of companies that are using AI, but at least as far as I get it, there's we haven't completely resolved the issue of trustworthy and explainability, but we're still using it, right? So any comment on this?
I can say that we can start, of course, depend on the application, in my opinion. But I think that because the trustworthy AI, in general, interpretable AI, can be used for many tasks. One important task, in my opinion, is the bug task. So understand why a model take a decision. So how to improve the data set, how to improve the model, what are the weakness of the model and of the data. So this is for one part. For the second part, the problem is that we have to understand how to put this neural network inside a probabilistic framework. So because the output of the network, what means the output of the network is not completely interpretable. And so I think that if we resolve this problem, maybe we can have more robust and powerful deep learning systems with many models that can help to make a better decision.
Very good point.
This is a risky one, but let me try to make a comment on it. I don't have an answer, okay? But let me say some comment. Of the one before, sharing data, allow me to say one comment. There are some areas where this already happens, for example, with healthcare. And with federated learning, you are able not to share the data because the GDPR doesn't allow, but you just share the weights within the topology. So we are already working in those cases where it's not exactly sharing of data, but already steps forward. In this case, I don't have the answer. I just want to say one thing that was interesting, that 1 year ago, it was approved the first medical device AI-enabled for colonoscopy, which is a big disease in terms of number worldwide, by the Food and Drug Administration. And that indeed was developed in Italy by a company that is a part of Cosmo Pharma. So if it is, if I don't have an answer to this question, what I can say that where it really matters, where there is a big problem, in this case, an health problem, an entity like the Food and Drug Administration already approved some devices, and I was proud to say that this is from Italy, and that's my contribute to this question.
I think it's a fantastic conclusion and motivation to go on. So with this, I close the panel, and again, let me say thank you to the panelists.